In the deep quiet of space, far beyond the shimmer of stars, an invisible storm is always moving. It crosses the dark gulfs between galaxies, slips through the veil of magnetic fields, and touches everything, from the tallest mountains of Earth to the faintest dust between worlds. These are the cosmic rays, fragments of the universe's most ancient energy, messengers from events so violent and so vast that even light sometimes fails to tell their story. For more than a century, scientists have tried to understand these strange particles that constantly rain down upon us. They are not light, yet they travel almost as fast. They are not radiation in the ordinary sense, though they bathe every planet and moon with silent energy. They are atomic fragments, mostly protons and helium nuclei, with occasional heavier ions, flung into space at incredible speeds. Each one carries the memory of some distant cataclysm, a supernova, a quasar's outburst, the shockwave of a galaxy colliding with another. When you step outside at night and look up at the stars, the sky seems calm, serene. Yet through that stillness, billions of these particles are passing through you every second. They are so small and so fast that you never notice. But their story stretches back to the beginnings of the cosmos itself. The earliest origins of cosmic rays begin with the birth of stars. Deep within those glowing furnaces, fusion reactions build heavier elements from lighter ones, hydrogen into helium, helium into carbon, oxygen, and beyond. But when a massive star reaches the end of its life, when its fuel is spent and gravity wins, it collapses and explodes as a supernova. In that moment, shockwaves ripple through the surrounding gas, and the star's material is hurled into space. The explosion releases enormous amounts of energy, creating magnetic turbulence and accelerating charged particles to nearly the speed of light. These are the seeds of cosmic rays. Each particle, a proton or atomic nucleus, is caught in the magnetic webs of the galaxy. The Milky Way's magnetic fields twist and scatter them, so that by the time they reach Earth, their directions are randomized. We can no longer tell precisely where each came from. The sky is filled not with beams, but with an isotropic sea of energy, washing over us from all directions. Yet some cosmic rays come from even more powerful engines. In distant galaxies, black holes at the centers emit jets of matter that stretch for thousands of light years. These jets, accelerated by magnetic and gravitational forces near the event horizon, can fling particles across intergalactic space. When those particles finally reach our solar system, they carry signatures of energies far beyond anything human technology can create. It is humbling to realize that the very air we breathe and the ground we walk upon are constantly showered by visitors from places we will never see. When the Austrian physicist Victor Hess first discovered cosmic rays in 1912, he did so by carrying an electroscope into the sky aboard a balloon. He found that ionizing radiation increased with altitude, contradicting expectations that it should decrease. The Earth itself was not the source. The sky was. From that moment, humanity understood that the universe was more dynamic, more charged with invisible energy than anyone had imagined. Cosmic rays travel through the galaxy much like dust in a cosmic wind. They spiral along magnetic field lines, occasionally colliding with interstellar gas and producing new particles in the process. When a high-energy cosmic ray strikes the nucleus of an atom in space or in the upper atmosphere, it produces a cascade of secondary particles, pions, muons, electrons, and gamma rays. These interactions light up detectors on Earth and in orbit, giving scientists clues about their nature and origin. The energy of some cosmic rays is astonishing. The most energetic particles ever recorded carry as much kinetic energy as a thrown baseball, concentrated into a single proton. Such a particle, moving near the speed of light, would take millions of years to cross intergalactic distances, yet it loses almost none of its momentum along the way. The universe, vast and nearly empty, offers little resistance. These rare ultra-high-energy cosmic rays remind us that space, though quiet, is never still. Scientists categorize cosmic rays by their origin. Primary cosmic rays are those that travel through space and reach Earth's atmosphere directly from their sources. Secondary cosmic rays are the byproducts of collisions between primaries and atmospheric atoms. Most of what reaches the surface of the Earth are these secondaries, particles like muons that can penetrate through rock and soil, even into underground detectors. There is a gentle rhythm to their arrival. On average, about one cosmic ray particle strikes every square centimeter of the upper atmosphere every second. But their energies vary widely. Most are relatively low energy, produced by ordinary processes in stars. A small fraction are incredibly powerful, marking the fingerprints of cosmic events beyond comprehension. When a cosmic ray enters Earth's atmosphere, it slams into a molecule of nitrogen or oxygen at nearly light speed. The impact shatters both, producing showers of new particles that continue downward like a branching tree. These secondary particles spread out, forming what scientists call an air shower. Some of these reach the ground, and a few even pass through our bodies. They cause no harm at such low densities, but they are constant companions of life on Earth, subtle reminders that we are part of a larger cosmic environment. In the early 20th century, as researchers began to study this radiation more closely, they found that it varied with time and location. The intensity was greater at the poles than at the equator, an effect caused by Earth's magnetic field. Charged particles are deflected by magnetic lines, meaning that the equatorial regions receive fewer cosmic rays than the polar regions, where the field lines open towards space. This discovery revealed that the Earth itself acts as a kind of shield, but an imperfect one. Even more intriguing is the way the Sun influences cosmic rays. The solar wind, a stream of charged particles from the Sun, carries its own magnetic field, forming a vast bubble around the solar system known as the heliosphere. This bubble modulates the incoming flux of galactic cosmic rays. When solar activity is high, the heliospheric magnetic field strengthens, deflecting more cosmic rays and reducing their number near Earth. During quiet solar periods, the field weakens, allowing more cosmic particles to enter. In this way, our planet is not only connected to the Sun but also to the broader cosmic sea beyond it. Over time, scientists have built instruments to measure and study these elusive particles. From ground-based observatories in Argentina and Utah to spaceborne detectors on the International Space Station, humanity has been listening to the faint whispers of the cosmic storm. The Alpha Magnetic Spectrometer, mounted on the ISS, continuously tracks high-energy particles, searching for clues to dark matter, antimatter, and the nature of the universe itself. Cosmic rays are not just curiosities of astrophysics. They shape the environments of planets and stars. They ionize gases in interstellar clouds, influencing the chemistry that leads to star formation. They may even have played a role in the evolution of life on Earth by affecting mutation rates and cloud formation. Some researchers propose that variations in cosmic ray flux over geological timescales could have influenced climate patterns, though this idea remains debated. At the deepest level, cosmic rays are windows into the fundamental processes of the universe. They allow us to study conditions that cannot be reproduced in laboratories, energies beyond those of particle accelerators, interactions that occur only in the hearts of supernova remnants and the jets of quasars. Through them, we glimpse the physics of the most extreme environments known to exist. The story of cosmic rays is also a story of patience. These particles wander through the galaxy for millions of years, deflected by magnetic fields until their paths become completely tangled. When one finally reaches our detectors, it carries information from places scattered across the Milky Way, a faint echo of ancient explosions. Scientists decode these echoes with careful measurements, building models that describe how particles propagate through interstellar space, how they lose energy, and how they interact with the interstellar medium. Imagine a single proton, born in the violent heart of a supernova 20,000 light-years away. It escapes the expanding shockwave, twists through magnetic field lines, and drifts for eons through the galactic disk. Along the way, it collides occasionally with gas atoms, generating faint gamma-ray emissions. Finally, after millions of years, it reaches Earth, colliding with an oxygen atom high in the stratosphere. That single collision becomes a cascade, briefly illuminating detectors far below. For a fleeting moment, the universe whispers a memory from its distant past. Every second, billions of such stories unfold invisibly above our heads. The atmosphere glows faintly with their energy, though we cannot see it. In that invisible rain lies a message about the structure of the cosmos, that even in the darkness between stars, matter and energy are always in motion, weaving a web of interaction across unimaginable distances. We live in a universe of silent storms, and cosmic rays are the fine dust of those tempests, the relics of creation and destruction, endlessly cycling between stars and space. Their quiet passage through our world connects us to events that shaped galaxies long before the Earth existed. In studying them, we learn not only about physics but about time itself, stretched thin across the cosmos. They are small, yes, a single proton, an atomic fragment. But in each one is a trace of something enormous, a force unleashed when stars die, a wave of energy born in chaos and traveling without end. In their simplicity, they tell us that even the smallest things can carry the weight of the universe. And as you listen, imagine those invisible travelers still moving through the quiet sky, through the vast emptiness that stretches from here to the edge of everything. The next time you feel the calm of night and the hush of the stars, know that above that silence, an ancient rain still falls, constant, gentle, and eternal. The invisible rain continues, endlessly descending upon Earth from every direction, each particle a silent messenger from the farthest corners of the cosmos. To the naked eye, the night sky is calm, the stars seem fixed, the air still. Yet through this apparent stillness, the atmosphere hums softly with the passing of energy. Every moment, countless cosmic particles strike the upper air, colliding with atoms and molecules, releasing showers of secondary fragments that spread like ripples in a pond. When those showers cascade downward, they carry traces of the original particle's journey, its energy, its direction, and its story. In those faint signals, recorded by detectors spread across deserts, mountaintops, and satellites, humanity learns to listen to the cosmos in a language older than light. The atmosphere serves as both shield and stage for these interactions. When a high-energy cosmic ray enters the upper layers, its collision with atmospheric nuclei unleashes a burst of subatomic debris. Among the fragments are pions, unstable particles that decay into muons and neutrinos. The muons, charged and relatively long-lived, continue downward, reaching even the ground and sometimes penetrating deep underground or beneath the ocean. They pass through us unnoticed, ghost-like, in numbers of thousands per minute. It is astonishing to realize that every human being is constantly traversed by these messengers from the stars. Though they leave no mark, they remind us that we live within an active, connected system, not isolated from the universe, but immersed within it. Early scientists puzzled over how such energetic particles could exist at all. No known process on Earth could accelerate matter to such extreme speeds. It was only when astrophysics turned its gaze toward the violent deaths of stars that the answer began to emerge. In the aftermath of a supernova, shockwaves ripple outward through expanding clouds of gas. Magnetic fields, twisted and amplified by the explosion, trap charged particles and fling them to relativistic velocities. This process, called diffusive shock acceleration, is now believed to be one of the main engines behind cosmic ray production. The mechanism is elegant. As particles bounce back and forth across the shock front, each crossing increases their energy slightly. Over thousands or millions of crossings, A few lucky particles reach incredible energies. But supernovae are not the only sources. In regions surrounding pulsars and magnetars, the remnants of collapsed stars with intense magnetic fields, matter is whipped into jets and vortices. These rotating remnants act as natural particle accelerators, capable of launching protons and ions to near light speeds. In galaxies with active nuclei, supermassive black holes funnel material into relativistic outflows, creating cosmic ray factories on a scale far beyond comprehension. Even in the vast spaces between galaxies, large-scale structures like galaxy clusters and filaments host shockwaves created by gravitational collapse. As matter falls inward, magnetic fields compress and accelerate particles. The universe itself becomes a network of accelerators, an intricate lattice of energy and motion. As cosmic rays travel through this interstellar and intergalactic medium, they encounter a complex web of magnetic fields. These fields scatter and redirect them, causing their paths to twist and turn countless times. This scattering explains why, when they finally reach Earth, their arrival directions appear random. We see them as a diffuse background, an isotropic haze of energy. Yet within that haze, subtle patterns emerge, small anisotropies that hint at nearby sources or magnetic structures shaping their journey. The journey of a single cosmic ray is a slow dance between order and chaos. It might begin near the heart of a dying star, then spend millions of years drifting through clouds of dust, deflected by invisible currents. Its energy, conserved through unimaginable distances, testifies to the enduring power of the events that birthed it. When it finally reaches our small world, that journey is over in an instant. A single impact in the atmosphere, a single spark of energy recorded by human instruments. To measure such fleeting events, scientists have created vast observatories spread across the planet. The Pierre Auger Observatory in Argentina, for example, covers an area of more than 3,000 square kilometers. It uses an array of detectors that record the showers of secondary particles created when a cosmic ray hits the atmosphere. By studying the timing, distribution, and intensity of those showers, researchers can infer the energy and composition of the original cosmic ray. Other observatories, like the telescope array in Utah, complement these studies, confirming that cosmic rays exist across a vast energy spectrum. The most energetic of them, the ultra-high-energy cosmic rays, are so rare that only a few strike each square kilometer of Earth's surface per century. Yet they carry clues to the deepest workings of the cosmos, pushing the boundaries of known physics. Some of these ultra-energetic particles exceed what's known as the Greisen-Zapp and Kuzmin limit, or GZK cutoff, which suggests that cosmic rays above a certain energy should lose momentum through interactions with the cosmic microwave background radiation, the faint afterglow of the Big Bang. When such particles are detected, it implies that they must have originated relatively nearby, in cosmic terms, perhaps within a few hundred million light-years. But the sources remain mysterious. No nearby object seems capable of generating them at such extraordinary energies. In this mystery lies one of the most compelling puzzles in modern astrophysics. Are there unknown accelerators in our cosmic neighborhood, perhaps active galactic nuclei, gamma-ray bursts, or exotic processes tied to dark matter? Or could new physics be at play, beyond the standard model of particles and forces? Each detection of a high-energy event becomes a potential key to unlocking these questions. To the scientific mind, cosmic rays are both problem and promise, a natural experiment carried out by the universe itself. Each one provides data about extreme environments impossible to reproduce on Earth. When they strike detectors, they let us glimpse particle interactions at energies a million times higher than those in our most powerful accelerators, such as the Large Hadron Collider. The cosmic laboratory is vast, and we are its quiet observers, deciphering the patterns left behind by invisible storms. But there is also a poetic side to this story, one that reaches beyond equations and detectors. Cosmic rays remind us that the boundaries between stars, planets, and life are not rigid. They blur and merge in a continuous exchange of energy and matter. Particles from distant stars pass through us. Atoms born in our own bodies may one day return to space. The universe is not a collection of isolated islands. It is an ocean of interaction, a ceaseless conversation carried out in the language of particles and waves. On longer timescales, cosmic rays may have subtly influenced the evolution of life itself. When they strike Earth's atmosphere, they generate ionization that affects cloud formation. Some researchers suggest that during periods of high cosmic ray flux, increased cloud cover could cool the planet. Others propose that radiation-induced mutations, caused by cosmic rays penetrating the surface, may have played a role in biological evolution. Though these ideas remain debated, they reveal a profound truth. The cosmic environment and the story of life are intertwined. Even now, cosmic rays reach the surfaces of Mars, the Moon, and the outer planets. Without the protection of a dense atmosphere or magnetic field, those worlds experience much higher radiation levels than Earth. Any future human explorers on Mars, for instance, will have to contend with this invisible bombardment, shielding themselves from particles born in the depths of distant stars. In deep space, cosmic rays pose one of the most serious challenges to interstellar travel. Unlike photons or ordinary radiation, these high-energy nuclei can pass through spacecraft walls, damaging electronics and cells alike. For long journeys beyond the heliosphere, beyond the Sun's protective magnetic bubble, the flux of galactic cosmic rays increases dramatically. Understanding their behavior is essential not only for astrophysics but for the future of human exploration. NASA's Voyager 1 and 2 spacecraft, now traveling through interstellar space, have measured this shift directly. As they passed beyond the heliopause, the number of detected cosmic rays rose sharply, confirming that the solar system's magnetic envelope had ended. Beyond that boundary lies the raw environment of the galaxy, a place where cosmic rays flow freely, shaped only by the magnetic fields of the Milky Way. Even at these immense scales, cosmic rays reveal the connectedness of everything. They show that energy and matter know no borders. What happens in a supernova a million years ago can influence a spacecraft drifting at the edge of our solar system today. The universe is a single organism, alive with motion and exchange. The stars breathe out, and the galaxies exhale streams of particles that cross the dark void, eventually mingling with other systems, other suns. Cosmic rays are one of the ways the universe circulates its energy, like blood through cosmic veins. And yet, for all we have learned, their origin story remains incomplete. Some particles seem to come from regions with no visible sources. Others arrive in patterns that defy magnetic explanations. There are hints that new physics may be hidden within their spectrum, perhaps signs of dark matter decay or interactions involving particles not yet discovered. The search continues, across mountaintops and orbital platforms, in underground laboratories shielded from background noise, and in the silent stretches of Antarctic ice where instruments like IceCube detect the faint glimmers of cosmic neutrinos. These parallel investigations into cosmic rays, gamma rays, and neutrinos converge on a grand goal: to map the high-energy universe in full, to see how energy flows from its birthplaces to its farthest reaches. The more we study them, the more cosmic rays challenge our understanding of time itself. Many of the particles striking Earth today began their journey before our species existed. Some began before the Earth had even formed. They have crossed epochs, witnessed the slow turning of galaxies, and arrived here only now, as we learn to listen. To detect them is to touch something ancient, to sense the deep continuity of the cosmos. They also remind us of humility, that our technology, our knowledge, and our presence on this small planet are but recent phenomena in a much older universe. We are newcomers, tuning into a signal that has been humming for billions of years. As you imagine these particles continuing their voyage, passing through the atmosphere, the ocean, the ground beneath your feet, and even through your body. Consider that they are the same particles that once traveled between stars, through interstellar dust and magnetic storms. Their energy is a residue of cosmic creation, a testament to the persistence of motion. The night sky above is therefore not just a view, it is an active field, alive with the unseen. Every direction you look, energy streams toward us, shaped by the memory of distant cataclysms. What appears serene is actually vibrant and full of conversation. In this quiet understanding lies something almost meditative, that in the grand silence of the cosmos, nothing is ever truly still. Even the emptiness between galaxies hums with the motion of charged particles, whispering stories older than time. And so, as the universe continues to expand and evolve, the cosmic rain will never cease. Long after our civilization fades, long after our sun cools and the planets drift into shadow, cosmic rays will still be traveling, carrying with them the last echoes of creation. Each one is a note in the great symphony of energy, a thread woven into the eternal tapestry of the cosmos. And as they move, endlessly and silently, they remind us that even the smallest fragments of matter can bear witness to the infinite. In the long history of cosmic inquiry, humankind has often gazed upward with questions too vast for words. We once wondered what the stars were made of, what forces governed their motion, and what unseen energies filled the space between them. Cosmic rays are one of those answers that deepens, rather than resolves, our curiosity. They are not merely radiation from afar. They are the connective tissue of the universe itself. Energy on the move, matter in motion, a bridge between the known and the unknown. When we study cosmic rays, we study the cosmos as a living process. Each particle is both traveler and historian, recording the conditions of its birthplace and carrying that record through eons of space. To understand these travelers, we must look not only at their origins, but also at what happens when they reach us, how they interact with matter, how we detect them, and what they reveal about the universe's hidden architecture. Every collision between a cosmic ray and Earth's atmosphere begins a kind of chain reaction. The upper layers of air, thin, transparent, fragile, serve as a vast detector, responding to invisible impacts from above. The moment a high-energy proton or nucleus meets a molecule of nitrogen or oxygen, it unleashes a burst of subatomic debris. Pions appear, then decay into muons, electrons, and neutrinos. Those muons, almost as light as electrons but hundreds of times more penetrating, slice through kilometers of rock and water before they vanish. At ground level, detectors listen for these whispers. In observatories around the world, instruments wait patiently. Tanks of water, sheets of scintillator material, sensitive photomultipliers, all designed to catch the faintest flicker of light or charge when a particle passes. A single event may trigger dozens or hundreds of sensors, allowing scientists to reconstruct the invisible cascade that began miles above. This work requires patience measured in years, for the universe's most energetic visitors arrive infrequently. Most of the time, detectors register a quiet rhythm, a steady drizzle of low-energy cosmic particles that form the background hum of the sky. But occasionally, there is a storm, a high-energy shower spreading across kilometers of atmosphere, lighting the instruments in perfect sequence. From these rare events come revelations about energies far beyond the reach of human technology. In laboratories deep beneath mountains, far from the background noise of radiation and electronics, other instruments search for cosmic rays' secondary traces. The muons that survive the atmosphere can penetrate even hundreds of meters underground, where they still leave subtle tracks. These underground observatories help scientists understand both the composition of cosmic rays and the shielding power of rock and soil. The science of detection has evolved through generations. In the mid-20th century, researchers used cloud chambers and photographic emulsions to capture the tracks of charged particles. They revealed the existence of new particles, including the pion, predicted by theory and discovered in the showers of cosmic rays. In those early years, before particle accelerators could reach high energies, the cosmos itself was our natural laboratory. Cosmic rays allowed physicists to glimpse the building blocks of matter, leading to discoveries that shaped the modern understanding of quantum physics and relativity. Today, we continue that legacy with instruments more sophisticated but no less humble in their patience. Space-based detectors like the Alpha Magnetic Spectrometer orbit Earth, continuously sampling the flow of cosmic particles. They separate protons from electrons, measure their energy spectra, and search for anti-nuclei, potential clues to the presence of antimatter regions in the universe. The data they send back is vast, requiring years of analysis, yet each number represents a real particle that began its journey light years away. High above the atmosphere, where the sky turns black and the air thins to nothing, cosmic rays interact directly with spacecraft. The steady rain of particles can interfere with electronics, alter memory bits, and create tiny glitches in circuits. For engineers, they are a challenge to be mitigated. For scientists, they are an opportunity. Instruments aboard satellites and probes record those impacts, translating them into energy measurements that reveal the shape of the cosmic spectrum. The cosmic ray spectrum itself is a story written in gradients. A smooth curve that bends and steepens at certain energies, features known as the knee and the ankle. These names may sound playful, but they signify deep physics. The knee, where the spectrum suddenly drops, suggests a limit to the acceleration processes in ordinary supernova remnants. The ankle, where the spectrum flattens again, points to the emergence of extragalactic sources, places beyond the Milky Way contributing to the cosmic particle flux. Each bend in that curve tells a story about where the universe becomes more or less efficient at generating high-energy particles. It is like reading a symphony score written in energy instead of sound, where every rise and fall corresponds to some hidden process among the stars. As we map that spectrum, we come closer to answering one of the universe's great questions. How does nature accelerate matter to such staggering speeds? Human accelerators use magnets and electric fields. The cosmos uses shockwaves, magnetic reconnection, and gravitational collapse. In both cases, the principle is the same: energy channeled into motion, motion transformed into structure. Yet even as we measure and model, the universe retains its mystery. The highest energy cosmic rays still defy easy explanation. Some carry more than 10 to the power of 20 electron volts of energy, a number so vast that it defies intuition. To give it meaning, imagine a single proton carrying as much kinetic energy as a tennis ball in motion. It is almost absurd to think such power could be concentrated into something smaller than an atom. But the cosmos does this effortlessly, as if to remind us how much of its strength remains beyond our understanding. The collisions these particles create in our atmosphere are, for a fraction of a second, miniature replicas of the most energetic conditions in the universe. They allow us to study particle interactions that may hint at new physics, processes that could reveal supersymmetry, extra dimensions, or unknown forces. Each cosmic ray, therefore, is not only a messenger but an experiment in itself, one that nature has been performing since time began. When scientists study the secondary particles produced in these collisions, they also detect flashes of light, Cherenkov radiation, named after the physicist who first described it. When charged particles travel through a medium faster than light can move through that same medium, they produce a faint blue glow, like the whisper of lightning underwater. In large observatories, tanks filled with pure water or ice capture this light, turning it into data points that trace the invisible trajectories of cosmic visitors. Deep in the Antarctic ice, the IceCube Neutrino Observatory listens for these glimmers, not from cosmic rays themselves but from their kin, neutrinos produced in the same astrophysical processes. Together, cosmic rays and neutrinos form a multi-messenger portrait of the high-energy universe. Where one particle is deflected by magnetic fields, the other travels straight, pointing back to its origin. By comparing their signals, scientists can triangulate the sources of cosmic power across billions of light years. In the stillness of the South Pole, under the unbroken night, those detectors watch for single flashes among the frozen darkness. They may wait hours, days, or weeks for one meaningful signal. But in that patience is something profound, an understanding that the universe does not speak loudly. It whispers. When we listen to those whispers, we hear echoes of creation. We learn that cosmic rays are not intrusions from beyond, but participants in the grand circulation of energy. They help shape galaxies, drive magnetic turbulence, and even influence the chemistry of interstellar clouds. When they collide with dust and gas, they ionize atoms, triggering reactions that create complex molecules, including the organic precursors to life. It is possible that without cosmic rays, the galaxy would be quieter but poorer in complexity. Their presence adds a subtle spark of activity, keeping matter alive with potential. In a sense, they are the universe's gardeners, stirring the soil of interstellar space. From this perspective, cosmic rays become more than physics. They become a metaphor for persistence, the ceaseless motion of the small carrying the weight of the immense. They remind us that energy, once released, rarely disappears. It transforms, travels, and returns in new forms, connecting distant epochs and places. The proton that strikes our atmosphere tonight may once have been part of a star that shone before humanity existed. The iron in our blood was once forged in the same kinds of stellar furnaces that generate these high-energy travelers. The connection is intimate. Cosmic rays tell us that the boundaries between self and cosmos are thinner than we imagine. Matter circulates, energy flows, and everything participates in a single story, one of transformation and return. The story of cosmic rays is not just one of origin and arrival. It is a story of relationship, of how these unseen travelers weave themselves into the cosmic fabric, influencing matter, energy, and even the rhythm of the galaxy itself. In the vast disk of the Milky Way, billions of stars orbit a common center, their gravity holding together clouds of dust, gas, and dark matter. Between them lies the interstellar medium, a tenuous mixture of atoms, molecules, and magnetic fields that fills the spaces between stars. It may seem empty, but it is alive with motion and energy. Cosmic rays course through it continuously, colliding with atoms, exciting molecules, and heating the gas. These interactions give the interstellar medium its delicate balance. Without cosmic rays, large regions of space would remain cold and still, too inert for new stars to form. But as cosmic rays penetrate clouds of gas, they ionize atoms, releasing electrons and creating tiny electrical currents. This process alters the chemistry of the cloud, producing new molecules, simple ones like hydrogen cyanide or ammonia, and more complex organic compounds that drift for millions of years through the dark. In this way, cosmic rays act as catalysts, quietly enabling the conditions for future generations of stars and planets. They are both destroyers and creators, breaking apart molecules with their energy, yet also seeding the processes that lead to renewal. Galactic magnetic fields guide their movement. Though invisible, these fields stretch across spiral arms, threading the galaxy like a network of unseen lines. Charged particles spiral along them, trapped in their gentle curvature, deflected and scattered countless times. The result is a slow diffusion that spreads energy throughout the galactic disk. Over millions of years, cosmic rays distribute their influence evenly, creating a kind of energetic equilibrium. If one could see the galaxy not in light but in cosmic radiation, it would glow softly everywhere, not bright like the stars, but humming with uniform intensity. That quiet background is one of the signatures of a mature, living galaxy, not static, but always in motion, balancing forces of gravity, magnetism, and radiation. Scientists have come to realize that cosmic rays carry about as much total energy as starlight and magnetic fields combined. This equality is not coincidence. It suggests a deep interconnection among the major forces shaping the galaxy. Starlight warms and illuminates, magnetic fields guide and protect, cosmic rays energize and stir. Together, they form a dynamic triad, three expressions of the same universal process of motion and transformation. As cosmic rays travel through the galaxy, some escape entirely, crossing the boundaries of the Milky Way and entering intergalactic space. There, they drift through the cosmic web, the vast structure of filaments and voids that connects all galaxies. These regions are not truly empty. They are filled with hot plasma, weak magnetic fields, and streams of dark matter. Cosmic rays, though sparse in number, can traverse these intergalactic bridges, carrying energy from one galaxy to another. In a sense, they are the emissaries of galaxies, maintaining a quiet exchange across the immense distances of the cosmos. At the largest scales, cosmic rays may even influence the evolution of entire galaxies. Their pressure contributes to the dynamics of galactic winds, vast outflows of gas that carry material from the disk into the halo. When cosmic rays push outward, they help regulate star formation by removing excess gas that might otherwise collapse too quickly. In this way, they serve as a kind of feedback system, maintaining balance between creation and restraint. The same processes occur on smaller scales within star-forming regions. When massive stars ignite, their radiation and stellar winds carve bubbles into surrounding clouds. Cosmic rays, accelerated by nearby supernovae, permeate those regions, further shaping the gas and influencing the next generation of stars. The interplay is delicate, yet constant. A cosmic cycle of birth, death, and renewal, powered by invisible energy. In studying cosmic rays, scientists also study time itself, not as a simple line, but as a continuous web of interactions. A supernova explosion may send particles streaming outward for tens of millions of years before they reach another world. By the time they arrive, the star that launched them may have long since cooled into silence, its light faded from the visible sky. Yet its energy still travels, encoded in motion, reminding us that in the universe, nothing truly ends. That persistence is one of the quiet lessons of cosmic rays. They show us that energy is not a fleeting spark, but a long conversation between creation and dissolution. Every collision, every particle, every subtle transfer of momentum adds to the story of cosmic continuity. For humans, this is more than a scientific observation. It is an invitation to see the universe not as static or cold, but as perpetually evolving. Every atom, every ray, every heartbeat of light participating in an ongoing exchange that has no final boundary. The instruments we build to study cosmic rays are, in essence, extensions of our senses, fragile attempts to hear what the universe has been saying since the dawn of time. The hum of a detector, the faint signal in a data stream, the pulse of a photomultiplier tube. These are translations of cosmic language into human understanding. Each measurement deepens our awareness, yet also expands our wonder. When the numbers are plotted on a graph, we see patterns that echo those found in nature everywhere. Power laws, exponential decays, smooth gradients. These mathematical shapes are not mere abstractions. They are the fingerprints of order underlying apparent chaos. They remind us that even the most random rain of cosmic particles follows rules, subtle, ancient, universal. One of the most haunting aspects of cosmic ray research is that we cannot see their sources directly. Because their trajectories are twisted by magnetic fields, they arrive at Earth as if from everywhere and nowhere at once. Only through statistical inference, correlation with gamma-ray emissions, and careful modeling can we guess their origins. It is like hearing the echo of a voice in a vast canyon, beautiful but directionless. To counter this limitation, astronomers combine data from many kinds of messengers. They study high-energy gamma rays, which travel in straight lines, to locate the regions where cosmic rays interact with matter. They measure synchrotron radiation, radio waves produced when charged particles spiral through magnetic fields, to map their paths. They track neutrinos, those ghostly companions of cosmic rays, to pinpoint the most energetic accelerators in the sky. This multi-messenger approach has begun to reveal connections between cosmic rays and some of the universe's most violent phenomena. Supernova remnants like Cassiopeia A, pulsar wind nebulae like the Crab Nebula, and active galactic nuclei emitting jets that stretch across light years. Each of these cosmic engines adds its own signature to the sea of high-energy particles surrounding us. In 2017, when scientists detected a high-energy neutrino coinciding with a flare from the blazar TXS0506+056, it confirmed for the first time that such active galaxies are indeed sources of cosmic rays. The finding was a milestone, a moment when the invisible became visible, when data converged into understanding. Still, for every answer we find, more questions arise. How do magnetic fields amplify in supernova shocks? How do particles escape from their birthplaces? Why do certain galaxies seem far more efficient at producing cosmic rays than others? These are not merely technical questions. They are inquiries into the very structure of cosmic order. The pursuit itself has a contemplative rhythm. The scientists who work on these problems spend years refining instruments, waiting for rare events, interpreting faint traces. Their patience mirrors the patience of the universe itself, which unfolds on scales of time almost beyond imagination. There is something deeply human about this process, the act of waiting, of listening, of searching for meaning in what cannot be seen. In every generation, new instruments extend our reach a little farther. Balloons rise above the atmosphere, satellites circle the Earth, probes venture into interplanetary space. Each carries sensors that feel the touch of cosmic energy and send back whispers of data. If one could slow time and watch the dance of these particles as they move through space, it would be a scene of quiet beauty. Invisible arcs looping through magnetic fields, colliding, scattering, merging, an endless ballet of motion across the darkness. Every path a story, every interaction a line of poetry written in energy and light. And yet, despite their immense power, cosmic rays obey the same laws that govern everything else. They are bound by relativity, shaped by magnetism, tempered by chance. Their motion reminds us that even in the universe's most extreme expressions, there is order, an elegance that persists no matter how vast the scale. When we fall asleep under the stars, the world seems still. But above, this eternal dance continues, billions of times per second. Cosmic rays drift through our atmosphere, through mountains and oceans, through our very cells. They leave no sound, no light visible to our eyes. Yet their presence links us to every star, every explosion, every transformation that has ever occurred. In the hush of the night, when all other motion slows, they continue, faint travelers moving through the unseen currents of the cosmos. They do not rest, and they do not end. The journey is the universe's quiet heartbeat, steady and endless. To understand cosmic rays at their most fundamental level, one must travel not outward but inward, into the heart of the quantum world, where particles dance in fields of probability and uncertainty. The visible universe is but one layer of reality. Beneath it lies the restless ocean of subatomic motion that gives rise to everything we see. In this domain, energy is not a continuous stream but a collection of quanta, discrete packets that move according to the strange and subtle laws of quantum mechanics. A cosmic ray, no matter how energetic, is still a single particle obeying these rules. It can behave as both wave and particle, interfere with itself, or even vanish momentarily into a virtual state before reappearing. When high-energy cosmic rays strike atoms in Earth's atmosphere, they reveal this quantum nature in spectacular ways. The collisions produce showers of secondary particles, pions, muons, kaons, neutrinos, which cascade downward like a luminous waterfall invisible to the naked eye. Detectors buried underground or spread across vast plains catch these fleeting visitors, translating their traces into data. Each detection is an event that connects the cosmic and the quantum, the infinite and the infinitesimal. A single muon passing through a detector may have begun its life in a galaxy millions of light years away, accelerated by forces incomprehensibly strong. Now, it glides silently through rock and air, slowed only slightly by its interactions with atoms. Its journey is a reminder that every instant contains echoes of eternity. Download 25 scientists studying these air showers build arrays that stretch across kilometers. Instruments like the Pierre Auger Observatory in Argentina or the telescope array in Utah detect flashes of light produced when cosmic rays strike the atmosphere. By measuring the pattern and timing of those flashes, researchers can reconstruct the energy and direction of the incoming particles. Some events are so powerful that they border on the unimaginable, single protons carrying energies greater than a baseball in motion. Such cosmic rays challenge our understanding of the universe's most extreme environments. Where could such acceleration occur? What natural processes could impart such colossal energy to a single particle? The leading theories point to phenomena of staggering scale: the turbulent shocks of supernovae, the magnetic maelstroms surrounding neutron stars, or the jets fired from the hearts of active galaxies. Yet even these explanations leave questions unanswered. For the very highest energy cosmic rays, no known mechanism seems sufficient. Some scientists speculate that they may come from exotic physics, the decay of hypothetical supermassive particles created during the Big Bang, or interactions involving dark matter. Others propose that they might be accelerated in intergalactic shocks formed by the collisions of entire galaxy clusters. Each idea opens new possibilities, each uncertainty deepens the mystery. But even amid these questions, one truth remains: the universe is constantly speaking through these particles. Cosmic rays are not interruptions in the silence, they are the silence made visible. Their rarity makes them precious. At the highest energies, only a few such particles strike a square kilometer of Earth each century. To detect them, humanity must watch patiently, continuously, for years. The quiet hum of a cosmic ray detector on a clear night is one of the purest sounds of modern science, not audible in air, but present in data, in the rhythmic recording of distant energy arriving here and now. Beneath the surface of the Earth, deep in mountain caverns or polar ice, instruments designed to catch even fainter interactions wait in near-perfect stillness. Experiments like IceCube in Antarctica watch for the faint blue flashes of Cherenkov light produced when neutrinos, particles often born alongside cosmic rays, pass through the transparent ice. These neutrinos are cosmic rays' silent companions, traveling undisturbed across billions of light years, immune to magnetic deflection or absorption. By studying both cosmic rays and neutrinos, scientists can trace the hidden architecture of the cosmos. Each provides a different perspective on the same underlying processes: the acceleration of matter, the conversion of energy, the transformation of chaos into structure. As our understanding deepens, the picture that emerges is one of profound unity. The same physical laws that govern the smallest quantum fluctuation also guide the birth of stars and the motion of galaxies. Energy and matter exchange roles, transforming endlessly in a cosmic cycle that has no beginning and no end. In this sense, cosmic rays are like the bloodstream of the universe, invisible yet essential, carrying the signature of every violent event, every transition, every moment of renewal. They move through the cosmos with purpose but without destination, driven only by the underlying geometry of space and the forces that shape it. To grasp the scale of their journey, imagine a single cosmic ray proton leaving the shock front of a supernova remnant. It may take tens of millions of years to reach our solar system, winding along magnetic field lines that twist and curve through the galaxy. During that time, entire civilizations could rise and fall on countless worlds, stars could form and die, and galaxies could drift slowly through space. Yet the particle continues, unaffected by time as we perceive it. When it finally encounters Earth, it enters the atmosphere with incredible speed, nearly the speed of light. In less than a second, it collides with a nitrogen atom, producing a cascade of fragments that spread across the sky like an invisible meteor. For a fleeting instant, the energy of a distant star's death is released in the upper air above us. That single event, undetected by human senses, is a perfect microcosm of cosmic interconnectedness. It is a reminder that we live in a universe of constant exchange, where every atom and every photon has a lineage stretching back to ancient stars and forward into unknown futures. On a deeper level, this speaks to the universality of energy. The laws of thermodynamics, first described to explain steam engines and heat flow on Earth, apply equally to the motion of galaxies and the behavior of cosmic rays. Energy can neither be created nor destroyed, it only changes form. In the slow unfolding of cosmic time, the same energy that powers a distant quasar may one day arrive here as a fleeting particle, transformed but eternal. There is a quiet comfort in that idea. It suggests that nothing is truly lost, that every transformation, no matter how violent or strange, contributes to the universe's continuous unfolding. Cosmic rays, in their ceaseless motion, embody this principle perfectly. They are the messengers of impermanence and persistence at once, the voice of the cosmos reminding us that change itself is the only constant. As human technology improves, our ability to listen to this cosmic voice becomes ever more refined. Future detectors may orbit beyond Earth's magnetic shield, or float in deep space far from the noise of solar radiation. They may capture particles from directions and energies we cannot yet imagine. Each improvement will open another layer of understanding, another glimpse into the engine room of the universe. Yet even now, with all our instruments and theories, there is still an element of mystery that remains untouched. The sheer randomness of when and where a cosmic ray will strike, the unpredictability of its energy and path, hints at the deep statistical fabric of nature, a balance between order and chance, necessity and freedom. Some physicists believe that cosmic rays could even serve as natural laboratories for testing fundamental theories. When particles collide at energies far beyond what human-built accelerators can achieve, they create conditions that might reveal new physics, the structure of space-time at the smallest scales, the behavior of quantum fields under extreme conditions, or the existence of unknown forces. In this way, the universe itself becomes the experiment, and we, the observers, merely interpret its outcomes. And perhaps that is the most humbling realization of all, that long before humanity sought to understand the cosmos was already performing its own experiments, writing its results across space and time in the form of cosmic rays. 29 Here to think of this while lying under the night sky is to feel both infinitesimal and infinite at once. Every breath we take contains atoms forged in stars. Every second, our bodies are touched by ancient radiation still traveling from events long past. The line between observer and observed blurs, and we find ourselves part of the very system we study. Cosmic rays remind us that we do not stand outside the universe, looking in. We are within it, immersed in its flow, participants in its great exchange of energy and form. As the night deepens and the stars grow faint behind drifting clouds, the cosmic rain continues, indifferent and eternal. It does not need us to watch or understand, and yet, through our curiosity, the universe comes to know itself. The story of cosmic rays is, ultimately, the story of that curiosity, of the mind reaching outward into darkness and finding reflection there. The influence of cosmic rays does not end in the void between stars. Their reach extends into the delicate atmospheres of planets, into magnetic fields, oceans, and even the fragile layers of life itself. When these charged particles reach a world like Earth, they meet a complex system of defenses. The magnetic field, the thick blanket of air, and the ozone layer that shields the surface from much of the sun's harsh radiation. But the protection is not perfect. Cosmic rays still find their way through, guided by invisible magnetic pathways, colliding with atoms high in the atmosphere and producing cascades of secondary particles. These showers, though invisible, shape the chemistry of the sky. When high-energy cosmic rays strike nitrogen and oxygen molecules, they trigger reactions that form new compounds, nitrates, sometimes even contributing to lightning or influencing cloud formation. Subtle, statistical, but real. The idea that cosmic rays might influence weather and climate has intrigued scientists for decades. It remains a delicate and debated topic. The suggestion that variations in cosmic ray intensity, perhaps linked to solar activity, could slightly alter the number of cloud condensation nuclei in the atmosphere. A small change in cloud cover could, over centuries, affect the planet's temperature. Whether the effect is profound or negligible, the possibility itself shows how deeply cosmic processes intertwine with terrestrial life. On other worlds, the influence is even more direct. Mars, with its thin atmosphere and weak magnetic field, lies open to the cosmic storm. Each second, high-energy particles bombard its surface, stripping away molecules, eroding the atmosphere, and shaping its climate over geological time. The story of Mars, from a once wet planet to the cold desert we see today, is also a story of how cosmic rays and solar wind have sculpted its destiny. Jupiter, Saturn, and the outer planets face a different relationship. Their immense magnetic fields trap cosmic rays, forming vast radiation belts that shimmer invisibly in space. The trapped particles spiral endlessly, emitting faint radio waves. Around these giant worlds, cosmic rays are not merely intruders. They become part of the planetary environment, an invisible ocean of energy circulating within magnetic boundaries. Even moons are not spared. On Europa, cosmic rays strike the icy crust, breaking apart water molecules and generating oxygen that may accumulate near the surface. Though the radiation would be deadly to unprotected life, it also produces chemical energy that could support microbial ecosystems hidden deep beneath the ice, in the dark oceans below. In this way, cosmic rays reveal a paradox. They are both destructive and creative, agents of both death and potential genesis. They can sterilize surfaces, shatter DNA, and erode atmospheres. Yet they can also create the very molecules that life requires, sparking chemistry where none existed before. Long before life arose on Earth, cosmic rays bombarded the planet's young atmosphere, striking primitive molecules and forging complex organics in the air and sea. These compounds, amino acids, nucleobases, simple sugars, may have drifted through the primordial oceans, combining under lightning, volcanic heat, and sunlight to form the earliest precursors of living cells. In this light, cosmic rays were not merely background noise but part of the story of life's emergence. They were the catalysts of possibility, stirring the chemical soup of the early Earth, turning energy into complexity. Even now, that influence continues, though subtly. Cosmic rays create a steady flow of radioactive isotopes in the atmosphere, such as carbon-14. This isotope, absorbed by plants and animals, allows scientists to measure the ages of ancient remains and artifacts. In a poetic sense, cosmic rays give us a way to read the chronology of life, their traces marking the passage of time itself. Every tree ring, every coral layer, every ancient bone holds a record of cosmic activity written in isotopes. When the intensity of cosmic rays rises, perhaps during a period of low solar magnetic shielding, the levels of carbon-14 in the atmosphere increase. When the sun's magnetic field grows stronger, fewer cosmic rays reach Earth, and the record dips. Thus, the sun and the galaxy leave a faint, rhythmic signature in the chemistry of our planet, one that can be read across tens of thousands of years. Beyond scientific measurement, there is a kind of serenity in knowing that life itself carries the mark of the cosmos. Every cell in every organism, including our own, occasionally feels the touch of a cosmic ray. Most pass through harmlessly, leaving no trace. A few may alter a molecule of DNA, introducing a mutation, a change that, over eons, contributes to evolution. This subtle interplay between radiation and biology connects all living things to the wider universe. It is a reminder that we are not isolated on a distant world but participants in a continuous cosmic process of transformation. The same particles that once surged from exploding stars now drift through us, altering us in imperceptible ways. They are the messengers of ancient light, the bearers of distant histories, and the instruments through which creation and change continue. When we think of cosmic rays in this way, they cease to be mysterious intrusions. They become reminders of kinship, of how intimately we are bound to the stars. From the earliest myths to the most modern physics, humanity has sensed this connection. We have looked upward and seen in the stars both our origins and our destiny. Now, through science, we understand that this intuition was not misplaced. The atoms of our bodies, the chemistry of our planet, the flow of energy that sustains us, all are shaped by forces that began in the hearts of stars and still travel across the galaxy as cosmic rays. To speak of cosmic rays is to speak of continuity, of the thread that links every event, every particle, every living thing. Their motion across space and time weaves the universe together, transforming isolation into unity. And so, even as we study their physics, their interactions, their spectra, their effects, there remains a quiet undercurrent of wonder. Because behind every equation lies the same simple truth. Energy moves, life responds, and the cosmos endures. The Earth, turning slowly through the interstellar medium, is constantly bathed in this invisible current. From dawn to dusk, from pole to pole, cosmic rays arrive without pause, steady and ancient. They have seen continents drift, oceans rise, species appear and vanish. They are older than our atmosphere, older than our world's magnetic field, older than the sun itself. In their persistence, they teach something profound about endurance, about the slow, ceaseless continuity of natural law. While civilizations rise and fall, while mountains erode and oceans shift, the cosmic rain continues, unbroken. Each time a cosmic ray strikes an atom in the upper atmosphere, a brief flash of light, a Cherenkov glow, may occur. Invisible to human eyes, it is a whisper of energy meeting matter, a gentle reminder that above the stillness of the night sky, there is endless motion. Then in the quietest moment, that motion never ceases. It is the hum beneath existence, the faint pulse of creation itself. If one could hover far above Earth's magnetic poles and watch with invisible eyes, one would see the delicate dance between incoming cosmic rays and the planet's magnetic field. Charged particles spiral along invisible lines of force, guided toward the poles where the field bends inward. As they descend, they excite atoms high in the atmosphere, giving rise to the auroras, veils of light moving gently across the polar sky. The same process occurs, in varied form, on other planets. Jupiter's magnetic field, immense and powerful, produces auroras far brighter and more energetic than those of Earth. Saturn's poles glow softly, threaded by similar currents. Even distant Neptune and Uranus, wrapped in tilted magnetic fields, show flickers of auroral light. These displays are cosmic conversations, the result of charged particles, solar and galactic alike, meeting the atmospheres of worlds. Through this lens, cosmic rays become storytellers. Their arrival marks the intersection between a planet's individuality and the galaxy's vast environment. Each world responds differently, its magnetic field and atmosphere shaping the encounter in unique ways. Some worlds absorb the radiation quietly, others flare with light. On Earth, the balance is delicate. Too much radiation, and life would struggle to endure. Too little, and perhaps certain evolutionary pressures would never arise. It is possible that the slow rhythm of genetic change, the occasional mutation sparked by a passing particle, has nudged life toward adaptability. Over deep time, these rare events accumulate, weaving the diversity of forms that fill the planet today. This idea, that cosmic rays participate in evolution, is speculative but poetic. It suggests that the same forces that sculpt galaxies may also whisper across the tree of life, shaping wings, fins, eyes, and minds. If true, then every living being is, in a quiet way, co-authored by the stars. The cosmic ray flux reaching Earth varies over millennia. As the solar system orbits the galaxy, it passes through regions of differing magnetic intensity and interstellar density. Sometimes we are shielded by magnetic clouds, sometimes exposed to more energetic radiation. These long cycles may leave subtle marks in climate records and biological evolution, echoes of the galaxy's own slow breathing. To study such effects, scientists analyze isotopes preserved in ice cores and sediments: beryllium-10, carbon-14, chlorine-36. Each isotope forms when cosmic rays strike atmospheric nuclei, and each settles into the environment, a tiny archive of past cosmic conditions. By reading these archives, we trace the history of our planet's exposure to cosmic radiation. Through these records, a story emerges not only of our atmosphere but of our place in the galaxy's motion. As Earth drifts through space, it experiences the cosmic weather of the Milky Way, a subtle, invisible climate driven by magnetic tides and interstellar clouds. Cosmic rays are the raindrops of that weather, falling continuously upon our world. Beyond Earth, spacecraft experience this radiation directly. Every probe that leaves the magnetosphere enters a realm filled with high-energy particles. Engineers must design thick shielding for delicate electronics, knowing that a single cosmic ray strike can flip bits of digital memory or damage a circuit. On long voyages, to Mars, to asteroids, or to the outer planets, cosmic rays become a constant presence, an invisible hazard and teacher alike. Astronauts on the International Space Station sometimes see brief flashes of light even with their eyes closed. These are not illusions but the marks of cosmic rays passing through the retina, triggering signals in the optic nerve. It is a reminder that the boundary between human and cosmic experience is thinner than we imagine. As we plan journeys beyond Earth, understanding and mitigating cosmic radiation becomes essential. Future explorers on Mars or the Moon will live beneath regolith shielding or within magnetic shelters, imitating the planet's natural defenses. In doing so, they will acknowledge the same cosmic environment that has shaped life for billions of years, adapting to it rather than escaping it. In the quiet isolation of deep space, cosmic rays may even serve as a measure of orientation. Their distribution and energy can reveal where the spacecraft sits within the solar magnetic field, offering navigational clues in the absence of stars. What was once a source of danger becomes a subtle guide. All of this deepens our awareness of connection. Cosmic rays tie every world and traveler to the galaxy. Whether striking an icy moon, brushing the hull of a spacecraft, or slipping through the clouds of Earth, they trace the same continuous path of energy that began in distant stars. There is a kind of humility in recognizing that these same particles have touched countless other places and beings, if such beings exist. Somewhere, perhaps on a planet orbiting a quiet red star, another atmosphere is being shaped at this very moment by the same cosmic storm. The physics is identical, the story, universal. If life arises there, it too will be touched by radiation, challenged and changed by it. Its evolution, like ours, may be partly written by cosmic rays. In that realization lies a profound symmetry, a unity that extends beyond biology, beyond even thought, into the essence of cosmic process itself. When astronomers map the galaxy, they find that regions dense with star formation also glow in gamma rays. These emissions mark the collisions between cosmic rays and interstellar gas, revealing zones of intense activity. In these same regions, new stars are born, an interplay of destruction and creation on a galactic scale. Thus, the Milky Way is not static but alive with exchange. Supernovae create cosmic rays. Cosmic rays heat the gas. Heated gas condenses into new stars. The cycle repeats endlessly, an equilibrium of birth and renewal. It is a process not unlike ecology on Earth, energy flowing through systems, sustaining diversity and balance. From this vantage, cosmic rays become agents of galactic metabolism. They move energy from one region to another, ensuring that no part of the galaxy remains inert. Even the emptiest spaces between stars are threaded with their motion, alive with faint pulses of power. For scientists, tracing these currents is an ongoing challenge. Each observation adds another piece to a vast puzzle. How galaxies breathe, how magnetic fields evolve, how matter circulates through the cosmic ecosystem. For dreamers and philosophers, it offers a deeper metaphor, that the universe is not a machine of isolated parts but a single, self-renewing whole. To listen to that whole is to step beyond words. It is to feel, in silence, the hum of existence, the slow, endless interchange of energy and form. Cosmic rays, though unseen, are the rhythm section of that universal song, keeping time across billions of years. The deeper we look into the universe, the more we recognize that cosmic rays are everywhere, not in scattered patches, but woven into the very structure of reality. Between galaxies, in the filaments that form the cosmic web, they drift with the magnetic fields that lace the void. In clusters of galaxies, they mingle with million-degree gas, storing energy that can shape the growth of entire systems. When astronomers use radio telescopes to map these enormous volumes, faint halos of synchrotron radiation emerge, the whispers of cosmic rays spiraling around magnetic lines over millions of light years. These halos are ghosts of past cataclysms, lingering signatures of vanished stars and black holes that once poured energy into space. The light from a galaxy can tell us how its stars are arranged, but the glow from cosmic ray interactions tells us how it breathes. Every explosion, every jet, every collision feeds a sea of high-energy particles that wander far from their birthplace, diffusing through the intergalactic medium. In this way, the death of one star contributes to the health of the whole. Energy is never lost, only transformed, from kinetic shock to radiation, from radiation to heat, from heat to the stirring of magnetic turbulence that will one day seed new galaxies. There is a rhythm to it, though too vast for human senses. We measure it only through patient inference. Slight variations in background radiation, changes in the intensity of distant sources, the slow drift of charged particles detected by spacecraft. Yet behind the data lies an immense serenity, the quiet continuity of process. In our laboratories on Earth, physicists attempt to recreate these cosmic conditions. Particle accelerators like the Large Hadron Collider accelerate protons to nearly the speed of light and smash them together, mimicking the collisions that occur naturally in space. But even our most powerful machines fall short of the energies reached by the highest energy cosmic rays, which strike the atmosphere with forces a million times greater. When such an event occurs, it is rare, perhaps one particle per square kilometer per century. Yet each time, an entire cascade of secondary particles showers downward, spreading across kilometers of ground. Arrays of detectors in remote deserts and high mountains wait for these flashes, counting them one by one, patiently collecting the messages that arrive from intergalactic distances. From the timing of those flashes, scientists reconstruct the energy and possible origin of the incoming particle. Some come from within our galaxy. Others, perhaps, from far beyond, from active galaxies whose jets extend for hundreds of thousands of light years. Each detection is a handshake across cosmic time, a tangible connection between human technology and events that unfolded long before Earth formed. These studies gradually reveal not only where cosmic rays come from but also what they can teach us about fundamental physics. At the highest energies, they probe the limits of known laws. When a cosmic ray collides with a molecule in the atmosphere, it briefly creates conditions similar to those just after the Big Bang, temperatures and densities that cannot be reproduced elsewhere. By analyzing the resulting showers, scientists test theories about the structure of matter, the behavior of fundamental forces, and the possibility of new particles beyond the standard model. In this sense, every cosmic ray is an experiment conducted by the universe itself, freely offered to any observer willing to measure and interpret. There is poetry in that generosity. While we build our instruments and theories, the cosmos continually supplies evidence, unasked, unending. It hurls information toward us in the form of light, neutrinos, gravitational waves, and cosmic rays. Our task is to learn to listen, to translate those signals into understanding. Listening to cosmic rays requires patience because their language is statistical, subtle, and easily masked by noise. Detectors must sit in silence for years, accumulating data. The resulting insights come slowly, like geological time compressed into mathematics. But when patterns finally appear, when flux variations align with supernova remnants or active galactic nuclei, the reward is profound. We glimpse the workings of nature on scales far beyond imagination. Amid all this precision, there is room for wonder. Imagine, somewhere in deep space, a single proton accelerated near the event horizon of a black hole. It spirals outward through jets of plasma, crosses millions of light years, threads magnetic mazes, drifts through the interstellar medium, and finally, after perhaps tens of millions of years, touches the upper atmosphere of Earth. Its entire journey has led to a brief, invisible moment, a point of contact between the infinite and the intimate. In that instant, physics and poetry meet. The particle's energy is transformed into a cascade of secondary particles, into faint flashes of light captured by photomultiplier tubes. Data scrolls across screens in a control room on a quiet night. And somewhere, a scientist smiles, recognizing the trace of a cosmic traveler that began its journey before humanity even existed. Such moments remind us that knowledge is not separate from awe. Each measurement deepens both understanding and humility. The more precisely we map the mechanics, the more mysterious the totality becomes. For every question answered, what is the energy spectrum? Where are the sources? A deeper one arises. Why does the universe contain such elegance at all? We might never know. But in contemplating cosmic rays, we touch a unity that transcends reason. They connect the microscopic with the cosmic, the transient with the eternal. They demonstrate that energy is the thread linking every scale of existence, from the quarks within protons to the vast structures of galaxies. Perhaps that is the greatest lesson, that there is no true separation in nature, only gradients of energy, different expressions of the same underlying continuity. The atom, the star, the galaxy, the consciousness that observes them, all are vibrations in one seamless field. When this thought settles in the mind, it brings a kind of calm. The idea of isolation fades. What remains is participation. The air we breathe carries the products of ancient cosmic rays, isotopes formed in the sky and mixed into oceans and soil. We are, quite literally, composed partly of cosmic radiation's aftermath. The universe has touched us at the atomic level, inscribing its signature within our bones. So when we look up at the night sky, the relationship is reciprocal. The light of stars meets the eyes of matter shaped by those same stars' past explosions. The cosmic rays still arriving complete the cycle, ensuring that the dialogue continues. Gradually, as this understanding deepens, scientific curiosity merges with quiet gratitude. The pursuit of knowledge becomes a form of listening, to the murmur of the cosmos through the static of radiation, through the whisper of detectors, through the pulse of imagination. The hum of cosmic rays is eternal, yet never repetitive. It carries the echo of all transformations, death of stars, birth of elements, evolution of worlds. And within that hum lies the steady reassurance that energy, and thus being, never truly ends. It changes form, continues, circulates, expands, and returns. In this awareness, the mind begins to rest. The universe is no longer distant or foreign. It is intimate, flowing through every atom of the body, every breath, every heartbeat. To feel that is to experience cosmic peace, the quiet recognition that we, too, are part of the great current that cosmic rays reveal. In the slow stillness of deep space, cosmic rays continue their ceaseless motion. They move through the interstellar medium as faint, persistent tides of energy. Long after the supernovae that birthed them have faded, their presence endures, a residual heartbeat of events that once blazed with unimaginable brightness. Every corner of the Milky Way hums with this quiet afterglow. The galaxy's disk, its spiral arms, and its halo are all immersed in a diffuse sea of relativistic particles, drifting between magnetic eddies, bouncing off shock fronts, blending and dispersing. It is a near-perfect equilibrium, the continuous injection of new cosmic rays from dying stars balanced by their gradual escape into intergalactic space. To study this equilibrium is to understand how galaxies regulate themselves. Too few cosmic rays, and gas collapses too easily, forming stars in unsustainable bursts. Too many, and magnetic pressure pushes the gas apart, slowing star formation. Somewhere between those extremes lies harmony, a self-tuning mechanism maintained by invisible currents of radiation. This is one of the quiet marvels of astrophysics, that chaos, when viewed from far enough away, behaves like order. Out of explosions and decay emerges stability, from turbulence, balance. Cosmic rays are the hidden mediators of that balance, subtle yet powerful, shaping the rhythm by which galaxies breathe. When astronomers simulate galaxies on supercomputers, they find that including cosmic rays changes everything. Without them, spiral arms collapse too quickly, and galactic winds are weak. With them, the models produce graceful disks, long-lived and dynamic. Cosmic rays act as the invisible architects of structure, guiding the motion of gas on scales that span light years. In this sense, they are not mere relics of violence but instruments of creation, sculptors of form on cosmic scales. Their pressure helps drive the winds that carry enriched material into intergalactic space, spreading the seeds of future stars. Download 44 He iron in a planet's core, the carbon in its life, the oxygen in its oceans, all are redistributed through the work of these unseen travelers. From this perspective, cosmic rays are not random or peripheral, they are fundamental participants in the story of matter. Their journeys connect the end of one generation of stars with the birth of the next. Through them, the universe recycles itself, turning destruction into renewal. When you imagine a galaxy in this way, as a self-regulating organism, it becomes almost alive. Every supernova is a heartbeat, every wave of cosmic rays a breath. The balance between gravity and pressure, between collapse and expansion, resembles metabolism on an unimaginable scale. The processes that sustain galaxies mirror, in their own way, the processes that sustain living beings. Perhaps that is why the study of cosmic rays feels so intimate despite its vastness. It hints at continuity between the grand and the minute, between the evolution of galaxies and the beating of a single heart. Both are governed by the movement of energy through systems that strive, always, for balance. And just as the human body carries traces of the cosmos carries echoes of life's striving. Within the mathematics of cosmic ray transport, diffusion equations, spectral slopes, cross-section coefficients, there is an underlying grace, as if the laws themselves were written to allow harmony to emerge from chaos. For the scientists who spend their careers studying these phenomena, the work can feel monastic. Long hours pass in silent control rooms, monitoring detectors for the rarest of signals. Data accumulates slowly, patterns emerging over months or years. But behind that patience lies devotion, a quiet faith that the universe, in its complexity, can be understood. And when understanding dawns, even briefly, it brings with it the same calm that the night sky evokes. The recognition that the universe is not merely vast, but coherent, not indifferent, but consistent, not hostile, but balanced. Such realizations do not diminish mystery, they deepen it. For in recognizing coherence, we also recognize that our own minds, capable of perceiving that coherence, must themselves be products of it. The ability to understand the cosmos is itself a cosmic phenomenon. When a researcher holds a trace of a cosmic ray in their data, a faint pulse in a detector, a spike in an energy spectrum, they are, in a literal sense, holding the afterimage of a star's death. They are touching the memory of an event that occurred across incomprehensible distance and time. And in decoding that memory, they participate in the same process that gave rise to their own existence. The chain is unbroken. The explosion of a massive star forges elements. Those elements form planets. Those planets host life. That life develops curiosity. And that curiosity, in turn, looks back toward the stars to understand its origin. Cosmic rays are part of that chain, messengers carrying the record of stellar life and death, allowing the universe to know itself through us. This idea, that the universe is self-observing, may sound poetic, but it is also a reflection of physical truth. Every act of measurement, every photon or particle captured by a detector, is an interaction between the cosmos and itself, mediated by consciousness. And yet, in the vast scheme, consciousness is no separate entity. It is a phenomenon that emerges from the same physics, from atoms arranged in patterns refined by cosmic history. The mind that contemplates cosmic rays is, in the deepest sense, composed of the same kind of matter those rays reveal. It is a humbling symmetry. The observer and the observed are built from the same energy, differentiated only by organization and awareness. When we study cosmic rays, we are not gazing outward into something alien. We are, in a quiet way, looking inward into the ancestry of our own being. The thought softens the edges of distance. The gulf between the Earth and the stars becomes less forbidding, more like a continuum. Cosmic rays are the bridge across that continuum, particles that traverse both realms without distinction. Even as they race near the speed of light, they are part of a conversation billions of years long. It is a conversation not in words but in interactions, in energy exchanges, in the quiet arithmetic of particles meeting particles. To listen to that conversation is to sense a profound serenity, the sense that nothing is wasted, nothing lost. Every motion contributes to the greater rhythm, every decay leads to renewal. Every burst of radiation becomes part of the background hum that fills all of space. The background itself, that faint, nearly uniform glow of cosmic radiation, is like a cosmic lullaby. It carries the echo of creation, the residue of events too ancient for memory yet still gently illuminating the present. Even in the darkest interstellar void, that glow remains, wrapping every atom in its faint warmth. As we lie beneath the night sky, that same background hum passes through us. The Earth is bathed in it, the atmosphere stirred by it, our bodies traversed by traces of it. We are never separate from the universe's quiet activity. We are immersed in it, always. If one listens deeply enough, not with ears, but with understanding, the constant passage of cosmic rays becomes an invitation to stillness. Each moment of awareness mirrors their journey, arising from the unknown, traveling through experience, dissolving again into the whole. And in that stillness, the cosmos seems not cold or remote, but peaceful, a place where even the most violent events serve a purpose in the larger balance. The death of a star, the scattering of particles, the gentle arrival of cosmic rays on a world billions of years later. All are parts of one immense cycle of transformation. Cosmic rays never rest. Even now, at this very moment, they strike the atmosphere, slip through oceans, pass through mountains, and move silently through the bodies of all who live. They are unceasing reminders that we exist in open exchange with the universe. They are not hostile, not alien, not intrusions from elsewhere. They are simply the motion of energy through space, the universal tendency toward interaction, diffusion, and balance. They are, in a very real way, the breath of the cosmos. From the earliest times, long before there were minds to name them, cosmic rays have shaped the chemistry of planets. When Earth was young, its atmosphere lacked the complex molecules needed for life. Lightning, ultraviolet light, and cosmic radiation struck its surface, transforming simple gases into more intricate compounds, amino acids, nucleotides, precursors of life's code. In those primordial storms of energy, cosmic rays played their part. Their collisions fractured molecules, creating radicals that combined into new forms. In that sense, every living cell today carries, deep in its molecular ancestry, a trace of cosmic radiation's creative spark. Even now, in the upper atmosphere, cosmic rays produce isotopes that circulate through the biosphere. Carbon-14 that we use to date ancient artifacts, beryllium-10 that traces the cycles of the Sun and Earth. These are the fingerprints of cosmic activity upon our own timeline, records written not in ink but in the nuclei of atoms. And beyond our world, they continue to write such records on other planets. The thin air of Mars is continuously etched by radiation, forming new chemicals on the surface. On icy moons like Europa or Enceladus, cosmic rays penetrate the outer crust, generating oxidants that might feed unseen microbial life in the dark oceans below. In that way, they are both destructive and sustaining, erasing and creating, sterilizing and enriching, depending only on circumstance. They embody the dual nature of the universe, the unity of opposites that defines all existence. Everywhere we look, that duality repeats. Stars die to create new elements. Black holes, symbols of destruction, generate jets that seed galaxies with energy. Even the decay of unstable particles brings forth neutrinos that travel untouched through space, carrying information across epochs. Cosmic rays fit naturally into this pattern, messengers of transformation. And in studying them, we uncover not only how the universe evolves but how it endures. For even as individual stars come and go, the total energy circulating through space remains constant. The universe is a closed symphony, changing in form, but never in essence. The cosmic ray flux we measure today is, in a sense, the echo of countless generations of stars. It is the music of supernovae long silent, of galaxies still forming, of black holes feeding in distant clusters. It is the soundless vibration of the universe remembering itself. In the deepest reaches of intergalactic space, cosmic rays drift endlessly, scattered by faint magnetic fields that thread the cosmic web. Some will never encounter matter again. They will wander indefinitely, carrying the memory of their origin until the end of time. Others will collide, lose energy, and merge into the background radiation that fills every corner of existence. Even the cosmic microwave background, the faint afterglow of the Big Bang, is now slowly being infused with the legacy of cosmic rays. Their interactions add tiny ripples, slight distortions, reminders that creation never truly ended, that energy continues to move, to interact, to evolve. This motion, constant and eternal, invites contemplation. For while the universe changes on scales beyond comprehension, the underlying principles remain the same. Energy and matter interwoven, gravity shaping structure, radiation carrying information. Cosmic rays are among the purest expressions of these principles. They are energy unbound, matter freed from structure, traveling freely across the abyss. And yet, their freedom is not chaos. It is guided by laws that are at once simple and profound. Each particle obeys the same rules of motion, the same quantum symmetries, the same conservation of energy. Across billions of years and billions of light years, those laws hold. The consistency itself is a kind of peace, a reassurance that the universe is trustworthy, that beneath all change lies order. For those who listen, the lesson of cosmic rays is one of endurance and connection. They reveal a cosmos where everything participates in everything else, where nothing is truly isolated. The particle that leaves a supernova may one day strike a molecule in the air we breathe. Between those events lie uncountable interactions, yet each is part of a continuous whole. When we fall asleep beneath the stars, the same invisible rain continues to fall, softly and eternally. It carries no threat, only the quiet assurance of belonging, a reminder that we are immersed in the same energy that fills all of space. Somewhere, in another galaxy, a similar rain falls upon another world, touching the surface of rocks, clouds, perhaps oceans. If there is life there, it too feels that unseen presence. Across the distances, all life, known or unknown, shares this same cosmic weather. It is the one constant in an otherwise silent conversation. From this realization arises a gentle humility. For all our technology, all our ambition, we remain small participants in a much greater harmony. The sun shields us, the atmosphere softens the impact, yet the cosmos always finds a way to reach us, not as punishment, not as test, but as reminder. A reminder that we are not separate from the whole, that even the boundaries we imagine, between here and there, life and matter, mind and energy, are temporary distinctions within a single field of existence. And when one looks at the sky through that lens, the fear of vastness fades. The stars no longer seem distant, they seem familiar, like reflections of something already within us. The cosmic rays that pass through us are proof of that familiarity. They are literal bridges between our inner and outer worlds. Perhaps this is why the study of cosmic rays feels both scientific and spiritual. It satisfies the intellect and calms the heart. It shows that even in a universe governed by physics, there is beauty, not accidental, but inherent. The equations that describe particle motion are, in their symmetry, a kind of poetry written in the language of mathematics. To study them is to listen to that poetry, to sense the deep order beneath apparent chaos. And to rest within that order is to find stillness, a stillness not of inaction, but of trust. We can imagine the universe as a vast sea of energy in perpetual motion. Each particle, each atom, each planet and person is a ripple within it. The ripples interact, fade, and reform, yet the sea remains. Cosmic rays are among the most energetic ripples of all, and their ceaseless passage through space is the universe's quiet reminder that motion and peace are not opposites. They are two sides of the same truth. Even the act of observation, the measurement of flux, the mapping of magnetic fields, all of it participates in that cosmic stillness. The mind observing is part of the same field it seeks to understand. Awareness itself is a structure of energy, shaped by the same laws. When seen from that perspective, science and reflection merge. The boundary between experiment and meditation disappears. Both are ways of perceiving the underlying unity that cosmic rays reveal. And in that unity, the great questions about life, time, and purpose become less urgent. Not because they are answered, but because they are absorbed into a deeper understanding. That the universe, in all its vastness, is not something to be solved but something to be felt. To feel it is to sense the eternal equilibrium, creation and decay, motion and rest, noise and silence, all interwoven into one continuous flow. Somewhere beyond the edge of our solar system, the last traces of the solar wind fade into the stillness between stars. There, the boundary of the heliosphere undulates gently, shaped by the pressure of interstellar particles and by the endless arrival of cosmic rays from beyond. Every second, trillions of them drift inward, whispering of distant places, of supernovae, of collapsing stars, of galaxies whose light has not yet reached us. Download 53. They move silently, bearing no message except the fact of their existence, the proof that energy forever seeks expression. They cross the heliopause like soft rain, slowed but never stopped, entering the domain of our star, curving through magnetic fields, glancing off planets and dust. Some will spiral into the sun and vanish in its fire. Some will slip through Earth's atmosphere, scattering into showers of secondary particles that flicker for an instant and are gone. Others will continue, unimpeded, through the void, through clouds, through us. A single high-energy proton may pass through a cubic centimeter of air once every few seconds. It goes unnoticed. No sound, no flash, only a faint exchange of momentum. Yet over time, those countless crossings shape the subtle chemistry of the air, the soil, the oceans. They mark the quiet participation of the cosmos in every living process. In mountain observatories, instruments wait in the thin air to catch them. Photomultiplier tubes watch for blue Cherenkov light in pools of water. Arrays of antennas stretch across deserts, listening for radio whispers as air showers unfold. Each detection is an instant of communication across billions of years, a star's farewell reaching our world long after its light has faded. When researchers collect the data, patterns emerge like constellations in a digital sky. They see hints of sources, pulsars, shock fronts, star-forming regions, active galactic nuclei. They trace the paths of particles through tangled fields, reconstructing histories older than the Earth itself. Slowly, patiently, humanity deciphers the stories written in motion, the stories cosmic rays have carried since the first galaxies formed. But beyond the numbers lies something quieter, the recognition that all this activity, all this ceaseless acceleration and decay, is part of one continuous breath. The universe inhales energy through collapse, exhales it through radiation, maintains equilibrium through the balance of opposites. Cosmic rays are part of that respiration, the subtle current that keeps space alive. If we could hear them, if our ears were attuned to particle motion rather than sound waves, the cosmos would not be silent. It would sing a slow, constant tone, a vibration that fills every corner of existence. That hum is older than light, older than memory. It is the sound of the universe maintaining itself. Even within our own bodies, echoes of that song remain. The carbon that builds our cells, the calcium in our bones, the iron in our blood, all were forged in stars that also gave birth to cosmic rays. The same processes that accelerate particles also created the matter that thinks and feels and wonders. When a cosmic ray passes through us, it meets its relatives. Star stuff encountering star stuff. In that realization, distance dissolves. There is no out there and in here. The energy that crosses the galaxy is the same energy that flows through the mind perceiving it. The boundary between observer and universe is a mirage of scale. Perhaps that is why contemplating cosmic rays can be strangely calming. They remind us that everything changes, yet nothing is truly lost. A proton accelerated to near light speed may wander for millions of years, but it never ceases to exist. It merely transforms, transferring energy, creating showers, joining atoms, radiating away. In every transformation there is continuity. The same is true of us. We, too, are temporary configurations of energy and matter, brief condensations in the cosmic flow. The thoughts that arise, the lives that unfold, are waves on the same sea that carries cosmic rays across eternity. To see that clearly is to rest, to let go of the illusion of separation. Imagine now drifting beyond the atmosphere, where the Earth becomes a pale curve below. Night envelops everything. Stars scatter across the blackness, But between them there is no emptiness, only the invisible motion of cosmic particles, countless and ceaseless. They glide through your field of vision though you cannot see them. Their presence is felt only as serenity, a kind of universal breath brushing past you. In that stillness, even time softens. The minutes stretch, the hours dissolve. 1,000,000 years could pass in the space of a heartbeat. The universe continues its patient dialogue. Creation, radiation, transformation. There is no hurry in its processes, only precision. Astronomers sometimes speak of cosmic ray age, the time a particle spends trapped within a galaxy before escaping. Typically it is a few million years. Then the particle drifts into intergalactic space, where it may remain until the end of all things. But end is only a human word. For energy, there is no end, only change of form. The particle's energy may redshift into microwave background photons, merge with dark matter fields, or become part of some future structure. Nothing is wasted, nothing disappears. As the universe expands, the density of matter and radiation thins, but the interplay endures. The last stars will someday fade, yet even in that far epoch, cosmic rays will still roam. Remnants of long-vanished galaxies moving through a cooling cosmos, carrying the memory of light. They will mark the persistence of motion, the refusal of energy to become truly still. To contemplate that future is to touch eternity, not in years but in awareness. The realization that even after everything familiar is gone, the laws that shaped it remain, unbroken, serene. The same equations will still hold, the same balance between gravity and motion, between energy and rest. And perhaps that is enough. The knowledge that existence, in some form, always continues. The universe does not end, it transforms into subtler expressions. Cosmic rays are one of those expressions, particles on the edge between matter and light, between creation and dissolution. As sleep approaches, let the mind drift with them. Picture a single proton leaving a distant supernova. It moves outward through expanding shells of gas, through clouds and fields, through centuries and millennia, untouched by friction, unstoppable. It crosses the void between stars, passes through nebulae, through the spiral arms of galaxies, through the intergalactic dark. It may, at last, enter the thin film of atmosphere surrounding a small blue world, spark a cascade of light, and vanish. Its journey complete, its energy shared. That motion, endless and graceful, mirrors the flow of thought itself, arising, traveling, fading, leaving traces that ripple outward. Each idea, each moment of understanding, is like a particle released into the great field of time. And just as no cosmic ray is ever truly lost, no act of awareness disappears. It merges with the continuum of existence. Now imagine the view from beyond galaxies, where space itself seems to glow with faint radiation. The cosmic web stretches in filaments and nodes, faintly illuminated by the relic light of creation. Along those threads, cosmic rays stream, weaving connections between galaxies, binding the universe into one continuous fabric. In that vast tapestry, our world is a single luminous thread, delicate but essential. There is peace in seeing the whole, in knowing that the universe, despite its immensity, is coherent. Every burst, every silence, every motion contributes to a harmony too broad for any one being to perceive. Yet to sense even a fragment of it is enough. The recognition itself is participation. As the narration slows, let the words fade into rhythm. The quiet rhythm of breath, of heartbeat, of cosmic motion. Each inhalation is a supernova's echo. Each exhalation, a gentle expansion of space. The same principles govern both, the same physics, the same serenity. You are part of that symmetry, a temporary shape in the universe's endless unfolding. You are made of particles born in ancient stars, crossed by cosmic rays older than life. You are, in every sense, the cosmos thinking about itself. So let the awareness widen until it becomes still. Feel the silence behind the words, the calm behind the motion. The stars above, the earth below, the particles between, all part of one continuous existence. Cosmic rays continue their eternal journey, weaving through galaxies, through atoms, through dreams. They ask for nothing, they carry everything. They are the quiet proof that the universe is alive with energy, with continuity, with peace. Let that understanding settle like starlight upon the mind. The vastness is not to be feared, it is to be felt. The universe does not stand apart. It holds you, moves through you, breathes with you. And as you drift toward sleep, imagine the soft rain of cosmic rays still falling, gentle and endless. Imagine each particle as a note in the infinite symphony of being, a lullaby composed by the stars themselves. Their song continues forever. The story of cosmic rays is, at its heart, the story of motion itself, of how the universe never truly stops, how energy forever finds paths through space and time. Every particle that crosses the vastness reminds us that even in apparent stillness, there is activity beyond measure. Cosmic rays are the restless messengers of the cosmos, tracing the invisible scaffolding of magnetic fields and galactic winds, carrying the signatures of creation across billions of years. To think about them is to think about the balance between violence and quiet. A supernova detonates in brilliance and chaos, yet from that chaos come delicate streams of subatomic travelers that drift softly through interstellar dark. The process that begins with unimaginable energy ends with near silence, particles gliding through air so thin they might as well be dreams. In that way, cosmic rays echo the rhythm of existence itself. Eruptions followed by peace, motion followed by calm, life following death, and then returning again. Science sees in these particles a language of data, energy spectra, flux distributions, isotopic ratios. Each measurement is a word in the cosmic vocabulary. Through them we learn about stellar lifetimes, about magnetic turbulence, about the birth of elements and the architecture of galaxies. Yet beyond the equations and detectors lies something subtler, the awareness that this knowledge connects us directly to the heart of the universe. When we measure a proton that left a distant star long before Earth had oceans, we touch the continuum of time itself. And as the numbers give way to feeling, a gentler insight emerges, that everything, from the smallest particle to the largest cluster of galaxies, participates in one continuous conversation. The atoms in your body are the slow echoes of ancient nuclear reactions. The cosmic rays that pass through you tonight may have begun the journey when the first life stirred in the sea. In that sense, observation is not just study, it is communion. Imagine, for a moment, that you could see every cosmic ray as a thread of light. The sky would shimmer with countless filaments, weaving through air and stone, through oceans and clouds, through you. The planet would glow softly within that invisible rain. Every moment, every place, quietly connected by energy too subtle for our eyes. The universe, even in its most silent depths, would appear alive, a vast organism of motion and exchange. This is what modern astrophysics reveals, not isolation, but relationship. The Milky Way is not a static disk of stars but a breathing structure, its magnetic fields bending and guiding streams of charged particles. Every supernova enriches the interstellar medium. Every outburst feeds the next generation of worlds. Cosmic rays are part of that cycle, the arteries of galactic metabolism. Through them, matter and energy remain in conversation, ensuring that the universe is not merely expanding, but evolving, learning, and transforming. As you listen, let that understanding soften into a feeling of belonging. The same physical principles that propel those particles also govern the electricity within your neurons, the chemistry of your cells, the warmth of your breath. You are not apart from the cosmos but an instance of it, one more pattern in the endless unfolding of energy. The motion of the stars is mirrored in the pulse within your chest. Now, let the mind drift outward. See the Earth from above, wrapped in its magnetic cocoon. Watch as cosmic rays graze its upper atmosphere, scattering into cascades of light that fade before reaching the ground. See the auroras shimmer near the poles, faint signatures of the same charged particles interacting with air. The planet breathes under their touch, luminous and serene. Farther out, the solar wind flows like a great tide, carrying traces of our star into interstellar space. Beyond that, the galaxy itself hums with radiation and field, with unseen trajectories of high-energy travelers that have no beginning and no end. The night sky, though still to our eyes, is a slow ocean of movement. To realize this is to sense that nothing in existence is truly still, and that this eternal motion is not chaos but harmony. As you breathe in, think of a particle crossing unimaginable distances. As you breathe out, imagine it passing gently through the atmosphere, through the quiet of midnight air. Each breath mirrors its journey, energy moving, dispersing, returning. You are, in a small and tender way, participating in the same physics that governs the stars. Let the scientific facts dissolve now into quiet assurance. The universe is continuous, balanced, complete. For every burst of creation, there is a moment of rest. For every particle accelerated to near light speed, there is the calm of the space it travels through. For every question, there is an infinite patience in the waiting for an answer. The detectors on mountain peaks still listen. The satellites still count invisible flashes. And above them, beyond reach, cosmic rays continue to fall, steady as breath, silent as thought. They are the heartbeat of the cosmos, too vast to hear but always present. So as you close your eyes, imagine that rhythm extending through you, through the room, through the planet, through the stars. The same laws that shape galaxies cradle you in their consistency. Gravity, electromagnetism, motion, and time, all working together in quiet order. Rest within that order. Let the mind drift where numbers blur into light, where knowledge becomes peace. You are made of the same particles that traverse the universe, and they continue their journey whether you are awake or dreaming. Somewhere, a cosmic ray leaves a dying star. Somewhere else, another one arrives at the edge of Earth's sky. Between those two moments, between departure and arrival, lies all of time, and you are part of it. The universe continues to hum, softly, endlessly. The stars wait. The night deepens. And you drift with them, calm, weightless, at peace.